page. So this is 262, and we are looking at number 5. 262, number 5 in the workbook. All right, so let's look closely at this. Especially if you asked about this, I want you to give me responses in the chat as I check on your understanding with this. And let's look, because look, the only difference between this and the first section is that these are exponentials. Okay, they're exponentials. The first section just had linear equations. So if you think of a linear equation, it won't matter if this was like our line right here. I'm just going to draw a line in here. Right? If this was a straight line, it wouldn't matter where I look for the slope, because if you're walking up a hill, the slope is the same all the way up the hill, right? But instead, with exponentials, we need to look at a specific interval, because look, the slope between 0 and 10 is where we're going to be looking. The slope between 0 and 10 is approximately that. It's going downhill pretty steep, right? That'd be like where you're climbing down with ropes. But look, as I get lower and lower down towards it bottoming out, now I have a slope that is much less. So we can't do these problems in the second section in the same way that we did the first section, 261. We need to pay attention to the interval. The interval tells us where we're looking on the graph or in the function that we'll deal with here. So I want to do all of this. I want to do all of the slope and y-intercept for this problem first. So when you have a graph, you don't have a lot to do. You don't have to use the slope formula. You can actually just see if it's possible to look at the graph and find your information. Okay. So what is the y-intercept for function b? Somebody tell me in the chat. What is the y-intercept for function b? Yeah, I'd say that. 600's down here. I see. This was the function that I just drew in to give another example from our last section. That is not the function. The function is the dark line here. So not 600. We're looking at this function here. Good, you changed it. It's up here at 800, okay? So look, I'm going to go ahead and put that over here. I'm going to put my y-intercept is equal to 800. That's one of the pieces of information I need, because I'm just going to be comparing my slope and my y-intercept, which is our initial amount. When time is 0, so at 0 days, you're at your initial amount, and that is where our y-axis is located. So our y-intercept is our value initially. Okay. Now, looking at this, we know the interval is between 0 and 10, so I know with this graph, I just need to look between 0 and 10. I need to see what's going on between 0 and 10. Okay. How do you know? Because the interval is talking about the domain values, our x values, and it's always going to give you your lower and your upper boundary. Okay, so we're not interested in what's happening out here. We're only interested in what is happening between 0 and 10. We're just looking right here on this part of the line. Okay, just that part. Now what you can do is go to the lower edge, find where the function crosses the lower boundary, 0. Go to the upper edge at 10 and find where the function crosses it at 10. Okay. So this is what I'm going to do here. When you have a graph, you can just remember that our slope, our rate of change, is the rise over the run. So since it's the rise over the run, going from this point to this point, I'm going to say this is right at like 475. Okay, that's how high it is. So look, the rise is from 800 going down, so it's negative, down to 475. So 800 going down to 500 will be 300. 800 going down to 500 is 300. plus another 25 from 500 here to get to the 475. So my rise is negative 325 over the run. Let's see. You go down 325, you go over to the right 10, and we're going to get our slope for this. It's going to end up being negative 32.5. Nice. All right, not bad. So look, when you have a graph, just like get a little happy with that, okay? Got it. Melanie, I didn't see your comment till now. Did my explanation right now help, or do you want me to try to teach it again differently? You want me to try again? Just put try again. No problem. Hey, no problem. So look, I'm gonna just write on this a little bit. Come on. You ever try to get one piece of paper out of a stack and you can't get it? Oh man. All right, look. If we had a situation like this, right? And it was like this. If I'm looking for the slope, right? I might look for the slope and say, the slope looks like it's about flat. Actually, the slope is about flat. Okay, that would be incorrect. If I said, hey, the slope looks like it's about 1 over 1, it's going up at about 45 degrees in this area, you're like, nah, maybe. But look, this part, now it's super steep. So because it's super steep and the slope is actually changing as this thing goes more straight up, then we know that we have to have more specific information. We have to say, okay, I want to know what the slope is, between 1 and 2. So that's where I would just be looking at this part of the function. I would just look between 1 and 2 and see, well, what is the slope between those 2 points? Those 2 interval parameters here. I'll pick the point there. I'll pick the point there. And I'm going to go ahead and make this 1, 2, 3. Okay. So I could do this where I say, well, this point is at 1, 1. This point is at 2, 3. And then I could do my, I could do this, y2 minus y1, x2 minus x1. I mean, I could find the slope from the points. But what I was saying is when you have a graph, you can count the slope. It's the rise up and down over the run side to side. It's always that ratio. So, for instance, if I'm going from here to here, if I want to find this slope, right? I look to see, well, what was the rise? What did I have to do? I had to go up positive 2. I had to then go over positive 1. So my slope for this interval of 1, 2 is 2. Okay. You see? For sure you're good? Well, actually, yeah, I see. Oh, okay. Yeah. All right, so we're going to jump back. That was just a little interlude. We have the y-intercept and the slope. Remember, and maybe put a note here so when you're studying, you can remember that this is the initial amount. Because time is at 45 days, 25 days, 5 days. 0 days is where you start. 0 days, since this is always time for these kind of problems, 0 days or 0 time is your y-intercept. All right, let's see. Now over here, let's look close because function A has more for us to do. But we've already learned these skills. All we have to do is remember our process in trying to create an equation to start. Let's see. A fully inflated beach ball is losing 7.5% of its air every day. The beach ball originally contained 800 cubic inches of air. Not quite 800 minus 475 because look, the fully inflated beach ball is losing 7.5% of its air every day. Okay. that would... So hold on that answer. Hold on that answer. I'm going to explain a little different, okay? Now watch. We're going to go to this. Oh, man. This again? Yeah. Okay. All right. I understand. You were talking about this function over here still. I have two different people saying two different things. So, okay. I'm not sure what these two different people saying different things, how to respond effectively. So I'm just going to say over here, yes, it was 800, right? 800 for the y-intercept. And we were looking for how to go down to 475. How much did we have to go down, right? How much we had to go down. So yes, I think what you were trying to ask for, and maybe I just figured it out, was this is going to be 800, right? Minus that 475. The difference between for the rise is from 800 down to 475. So that's how we get, when we combine this, we get the -3. Dang it. We get 800 minus 475, and that gives us our -325. All right. Yeah, you got it, Melanie. You got it. So it might have been confusing because I was talking to another student. Okay. So let's go back to it. No worries. All right, look. A fully inflated beach ball is losing 0.7 or 7.5% of its area every day. The beach ball originally, so we're just looking and learning the words, and what it means in the context. Originally contained 800 cubic inches. So watch. I know my initial is always my A value. And then if it's losing, is this a growth or decay? Decay, thumbs down. Growth, thumbs up. Is this growth or decay? If it's losing air. Good. 1 minus this as a decimal. Okay. And it's losing it every day. So at one day, it's had the entire decay already. Okay. So here we go. Let's go ahead and just simplify it one more step. That's going to be, what is that? 0.927. Let's see. 1 minus 0.075. Nope. 0.925. Oh, that's a 5. That's why. All right, we got our equation now. We know that for this, our y-intercept, which is our initial amount, when time is 0, we're going to have 800. So already, I look over here, we have the same exact initial amount. All right, that's going to be part of our answer. Next, we have to find the slope. All right. Now, the slope is between 0 and 10, so watch what I'm going to do. I'm going to plug in 0 and 10 so that I can get 2 points, and then plug it into my slope formula. So the main goal here is to use the equation. The reason why, I just need to zoom out a bit. Yeah. The reason why I chose 0 and 10 is because the interval is between 0 and 10. 0 for x, 10 for x. So if I plug in 0 and 10 for x, I'm going to get my y values, which will be my 2 points to plug in and find my slope. So it's each step we've done in prior sections. Okay, so this is just the first step. We're doing f of 0. And actually, we already know this, but I'm going to do it anyway. 0.925 to the 0. What is anything to the 0 power, guys? Anything to the 0 power? 1, 1, 1. Good. Not 111. It's just 1. So when I plug in 0, I get 800. And I kind of already knew that because my y-intercept is 800. So it kind of makes sense. It definitely makes sense that that's going to be 800. Now, next, let's plug in f of 10. 800, 0.925 to the 10th. Okay. And that's 0.925 raised to the 10th. All right, that's 0.458. Let's just multiply that by 800. All right, so when we plug in f of 10, we're going to get 366.87. 366.87. All right, now I have my points. Let's label them. x1, y1, x2, y2. Last step, we're going to plug in here and find our slope and compare them. Y sub 2, 366.87 minus y sub 1, 800. It's going to be negative. Okay. Next, x sub 2, 10 minus 0. So we're going to end up with, let's see, we got to subtract 800 from that. We're going to end up with negative 433.13 over 10. So you just divide that by 10 and you get negative 43.31. Ooh. All right, here we go. Let's go ahead and compare them. We just needed the y-intercepts and the slope. We have them. So I would say this about these two functions. Both functions a and b begin with an initial value of 800. Both functions a and b begin with an initial amount of 800. But seeing that they're both negative, we'd have to talk about which is decreasing faster. Because they're both negative, we'd talk about which is decreasing faster. Okay, so I would say both start with the same amount, but function A loses more air, or loses air at a faster rate, or decreases at a faster rate. Because look, negative 43 is less than negative 42. Okay, function A decreases faster. Especially if you ask for this question, go ahead and give me a thumbs up or thumbs down. What do you think? Great. Great. All right, anybody else want to see any other problems? This was number 5 and 2.6.2. All right. All right. Well, that was a good question to look over. I got a good 15-minute video for this. I'm going to stop it, and we're going to transition. Okay, guys? So this is due